Yeah, first question, guys. Inferential statistics. Very good. One. Statistics is really a concept which is basically telling us on conditions for population. Inferential statistics. We infer conditions or statements for population, for generic population. But in order to do this inference, we need to look at sample data, because we cannot get population data. We get sample data, and we perform our statistical calculations on sample data. So the results, which are called as the statistics, are used to infer statements for population. That is known as inferential statistics. Next. In order to do inferential statistics, we need sample data, right? So what are the techniques that we know for sampling? Oh, okay, my voice is breaking. How about now? Is it still same? Okay. So sampling techniques, we can broadly name them as biased and unbiased, right? Biased and unbiased. And we also call them as probability and non-probability techniques. And we already have come up with all these things in the book, right? And a lot of people are taking advantage of this book. You should also take the advantage. There's the book. Yeah. Just expanding this. Structured, unstructured, right? All these things are basically what we discuss in our sessions. So in a structured way, all these things are explained here, right? Random variable, probability, inferential statistics. You can see here, biased sampling, unbiased sampling, probability or non-probability sampling techniques. And yeah, you can see here, non-probability sampling techniques, probability sampling techniques. There are few few points mentioned here. All right. So sampling techniques. Next. When you're trying to do inferential statistics, the first thing probably you will attempt to do is hypothesis testing. What is hypothesis testing? Why is it used for? Why is hypothesis testing used for? Or what is it used for? It will take time, Kiran. We are preparing that. We underestimated the effort that goes into preparing a book. It's still under development. We're still preparing that. So it will take some time. Yeah, for making decisions or not? No, for making decisions. That's it. What decision is depending on the business problem. To draw insights about population, okay, comparison of two data sets, okay. Yeah, hypothesis is a form of inferential statistics, of course, yes. No, inferential statistics is basically to estimate a condition. Hypothesis testing is basically helping you to identify whether that estimation is acceptable or not. So hypothesis testing is proving whether the chance of the estimated value is falling in the accepted region or not. Can we accept the value or not? Right? So hypothesis testing is a measure of our estimation being true or false. Now, when we talk about hypothesis testing, we immediately have to talk about, inferences, or I should say hypothesis statements. By default, what is the default condition called as in hypothesis testing? Null hypothesis, very good. It's the default condition, or it says continue what you are currently doing. Now, if this action that you're currently doing is wrong, then we go for alternate hypothesis. Right? That's represented as H1. Okay, next. What conditions should we, or I should say, what is the condition called as when we take action even if the significance of the test fails? Yep. Even if the condition is false. Yeah. Very good. Type 1 error, which is represented as alpha. Type 1 error says taking action even when it is not required. So whenever we talk about hypothesis, immediately you have to come up with this table, right? So we have H0 here, H1 here. Here also we say H0, this is the true conditions assume, and this is H1. Now if H0 and H0 are true, then this is called as, what is this condition called as? Condition, name. Confidence, very good. And it is represented as 1 minus alpha. It's called as confidence. And this is type 1 error, which is represented as alpha. Now, if H1 is true and H0 is considered, then this is type 2 error, which is represented as beta. And what is the quadrant called as? Power. This is called as power of the test, and this is 1 minus beta. Right? So this table you have to by heart with respect to hypothesis testing. This is something that you have to embed into your brains. So I'll ask a question on here. What is type 2 condition? Explain type 2 condition. You should be able to explain. Yeah, what is type 2 condition? When the current condition that we are performing is false, but still we continue doing the current decision, current action. That's when your type 2 error occurs. That means you need to take action, but you're not taking the action. Failing to reject a false null hypothesis. Right? That is type 2. Okay, what is criteria? What is the criteria for concluding on decisions? What is it called as? What is it called as? Significance level. 1 minus alpha is confidence. Alpha is significance, and this is the criteria we are talking about. This basically says the chance of, or I should say maximum chance of going wrong, which is accepted. If you go wrong beyond this, then yes, it is not accepted. So the criteria for conclusion is this parameter or this metric, right? We call it as level of significance or significance level. Now, question to you all. The default significance level is 0.05. Very good. But can we alter the criteria of significance? Yes, we can. Rule of thumb says 5%, but we can also have 10%, we can also have 1%, we can also have 8%, any random number based on the business requirements. Right? Okay. What is the process of hypothesis testing? Steps to perform hypothesis testing. Yeah. Very good. So you have to generalize, guys, not for continuous and discrete, not like that. You have to generalize the process here. Crisp DM, remember the crisp DM logic, okay? Business understanding, which basically helps us to frame the hypothesis, null hypothesis, then collect the data. Here we are collecting the sample data. Then we perform the test. That's your mining, data mining. And we get the random chance or likelihood of the estimate, right? Probability. And based on the probability, we will conclude. That depends on the level of significance. Right? Those are the steps, high level steps. All right. How do we take that decision? What are the decision parameters? Decision parameters in hypothesis. Yeah. Decision parameters in hypothesis. Decision parameters okay, null hypothesis, alternate hypothesis, and significance level, guys, alpha. These are good enough for us, right? Test statistic would be there. The test statistic will give us the chance, probability, which is likelihood of the estimate, right? And based on the level of significance, we basically go about accepting or rejecting the default condition, right? What are those conditions? How do we interpret this? If the significance level, p-value, is greater than the industrial standard 0.05, then we say P high null fly. P high null fly. That means go with the default condition. If significance level is low for the test, then you say P low null go. That means you can take an action. Yeah. Next. Yeah, next. What is parametric test and what does non-parametric test means? Parametric versus non-parametric, yes. Let me write that. What is parametric test? Or test? We are estimating a parametric test. Non-parametric is done to check which parameter can be applied. No guys, come on. Anyone, what does parametric test and what does non-parametric test means? Okay. So parametric test assumes that the data follows normal conditions. Parametric test looks at the distribution of the data. Right? We make assumptions about the distribution of the data, and based on that, we try to make the inferences. In non-parametric test cases, we do not look at the distribution of the data. That's the primary difference. Can you label names and give some examples? Parametric test cases. T-test, Z-test, PATE test, ANORM test, ANOVA test, all these are parametric test cases. Non-parametric test cases are your chi-square test, Mann-Whitney test, Moods median test, Kruskal-Wallis test. These are non-parametric tests. Yeah, parametric and non-parametric. Okay. When do we go with t-test and when do we go with z-test? When should we use t-test over z-test? When the population standard deviation, which is sigma, is not known. When we go with, then we go with t-test. If we know the population standard deviation, then we go with the standard normal statistic, z-test. Yeah. Oh, next. What will I do, or what test will I go with? What test should I apply for two populations, two normally distributed populations having same variances? Yeah. So what test should I go with? Two sample t-test. Very good. We go with two sample t-test. Okay. What is paired t-test? Paired t-test. When external conditions are same that we used, okay, wonderful. Very good. So paired t-test basically is applied on normally distributed data for comparing the populations of normally distributed data, which are of course continuous, right? And I should say, when the external conditions for both of these populations are similar, right? When conditions will be similar, we apply this paired t-test. Very good, Lokesh. Next, let me write another question. Okay, what is ANORM test? Full form is analysis of means, but what does ANORM tell us? Anyone? How is it different from ANOVA? Okay. Analysis of means is basically trying to tell us which of the sample means, and then we have multiple populations, basically will help us identify which from the population mean, overall mean. Okay. This is the and now yeah, is it okay? Now, okay, let me just check. Huh? Yeah, give me a second. I'm just trying. Still not okay? I just changed my connection. Now okay, right? Okay, yeah, fine. So we are talking about a norm test case. A norm test case basically is used when you have greater than two populations, and we are trying to compare mean 1, mean 2, mean 3, so on and so forth with respect to population mean. Right? Which of the means of the populations are statistically different from the overall mean? And when you perform anorm, you'll get a anorm output, graphical representation of your population mean and your regular means. And you'll see which of these populations or which of the samples that you have is very different, statistically different from the overall mean. That's a norm test case. Right? Okay. Next. What is ANOVA test case then? We discussed about anorm. What is ANOVA? ANOVA means analysis of variance, right? It is used to check if the means of these populations are statistically different from each other. We are verifying whether the means are different from each other, whereas anorm tells whether these means are different from the overall mean. Right? So that's the difference. Yep. Okay. What will be the parameter, or what would be the metric, I should say, that is used in non-parametric test cases? Yeah. For doing conclusions, what is the metric that is used? Yeah. Non-parametric test cases, what is the metric used? No. What is the underlying assumption, the first assumption that we do for non-parametric test cases? Yeah, good, funny Kiran. What is the underlying assumption, guys, to begin with for non-parametric test cases? Okay. The first underlying condition is that the data is not following normal distribution. Exactly, data is not normal. So you cannot go with mean comparisons. Right? We cannot go with mean comparisons. We have to use median here. Yep. What is F statistic? How do we calculate that? Very good. F statistic is basically the ratio between groups, the variability between the groups over within the group variability. Right? We take sum of the squared distances of the within group values within the group data points, right? Over, between by within, my bad. Error, MSC is in the denominator. That means we are looking at within the group variability in the denominator and among the variability, among the group's variability over the numerator. So it is MSTR treatment, mean square treatment over mean square error. So when I say treatment, it is the sum of the squared deviations between groups. So I should say X bar minus mu, grand average. Sum of the squared differences is what we take. And this is X minus X bar whole square. right? So this is how we calculate F statistic. Now, what can be the range of F statistic? Yeah. Range. Mm-hmm. It's a statistic, it's not a probability, right? Yeah. Can it be negative? Very good, Lokesh. F statistic will always start with 0. It cannot be negative. Because why? You can simply see you're taking squared values, so you'll never get negative in this calculation. This is an interview question that we can, it can be asked. Right? So it can never be negative. All right. Now let's talk about yesterday we started with this, right? Evaluation techniques. Now, how do we measure, let's say, the goodness of it for any, let's say, model, any supervised learning model? Yeah. R squared. R squared will be there for regression, right? I'm talking about supervised learning techniques, any supervised learning techniques. Right fit, how do we get that right fit? Training and test, accuracy, errors, guys. We evaluate the models based on the errors, error metrics. Right? So evaluation of a supervised learning technique how does evaluation of a supervised learning technique is done? So it is by comparing the actual work predicted. Because in supervised learning techniques, we will know what is the variable of interest, right? So we will be comparing the output, right? And when we do the measure of deviation, we will come to know which model is performing better. So here we call it as error functions. Yeah, we can call them as error function. Right. We've discussed about k-means also, right? Let me ask a question. What is the difference between KNN and k-means? Yeah. What is the difference between KNN technique, KNN classifier technique, and k-means clustering? Very good. Kiran, Bhavna, very good. Suresh, very good. Yes. KNN is a supervised algorithm, supervised learning technique or learning approach, whereas K-means is a clustering approach, clustering algorithm, which is unsupervised. So one is used for predictions or classifications. The other one is used for descriptions, right? Descriptive statistics. Wonderful. And what else do we have? Let me think of. Okay, we'll talk about I'm just thinking of, shall we go with, okay, decision trees. Well, let's go with the decision trees questions. Okay. What all the nodes do we have in decision tree? Mm-hmm. Very good. 3 nodes. There are 3 nodes in decision tree. Isn't it? Root node, branch node, and then we have leaf node or terminal node. Right. Decision trees are classifiers only. Very good. Santosh, wonderful. Decision trees, or I should say types of decision trees. Yeah, what are the types of decision trees? There are 2 types of decision trees. Classification based decision trees, regression based decision trees. Exactly. So your decision trees can work both on categorical data and continuous data. Right? So there are 2 types: categorical variable decision trees, continuous variable decision trees. Okay. What are the major questions that we need to look at? Steps. What are the steps to be performed for developing a decision tree? What are the major aspects that we need to look at? Very good. We have to identify the variable which helps us get least entropy, maximum information gain. Statistically, we will be calculating the maximum information gained. Or in simple terms, we need to identify the attribute which is used to split the data so that we get the most homogeneous pair of branches. Right? So the steps are: identify the root node which gives us the most homogeneous branches. Right. Now, what are the advantages of decision trees? Advantages. Very good. Interpretability, understanding basically. Yes, distribution of the data is not important. That is, outliers are not affecting the output. It can be used both as regressors and classifiers. Very good. It can also be used for factor analysis. Which factor is more important for your output variable? Right? So that is also another advantage that we have in decision tree. Now, what are disadvantages? Overfitting, that's the first thing that we need to talk about when we say decision trees. Overfitting. In fact, decision trees are the algorithms which are most prone to get affected by the overfitting. I mean, it's the algorithm which is most prone for overfitting. But how can we control the overfitting in decision tree? Very good. Pruning. What is pruning? Very good. Pruning means cutting the tree, and types of pruning, we say pre-pruning and post-pruning. Very good, guys. Very good. Okay, what does entropy calculation means? What is entropy? Measure of impurity. Entropy is nothing but measure of impurity or measure of variability. Very good. What can I ask? Okay, what all parameters what all arguments that can be used for decision tree growth? Yeah. Very good. Depth. Number of leaf nodes. Number of leaf nodes or okay. Okay. So there are multiple variables. We'll start with depth, of course. In fact, how many samples should be there? How many nodes should be there when you are splitting a branch, splitting the branches? Right? If you're splitting, then how many records, minimum number of records should be there in each of the branch? That's one of the parameters that we consider. Then we can also say minimum samples that are required in the terminal node also, not just at the branches, but at the leaf node, at the end leaf node, how many samples or how many records should be there? Yeah? Depth of the tree, of course, you already know. How many branches? Total branches from root node. And maximum number of terminal nodes also something we can pass on. And how many features should we consider? How many variables should we consider for partitioning? If you have 20 variables, should I use all the 20 variables or should I use only 10? That is also a parameter that we can apply. Yep. So these are various arguments that are used for fine-tuning your decision tree algorithm. Okay. What is R package? Do you remember R package for tree development? Very good. Only C50. Do we have any other algorithm or package? R part, okay, one of those popularly used. Very good. C50. R part. Oh yeah, very good. One which is another one which is very commonly used. The basic ones. Tree. C tree or tree. That is also very commonly used. Tree. In Python, we have sklearn algorithm. In Python, there you have function called tree. Right? So those are basically commonly used functions for trees. All right. Let's now look at, okay, how do you improve decision trees accuracy? Pruning, okay. Santosh, good. By using ensemble techniques. We use ensemble techniques. Yeah. What all various ensemble techniques are known to you? Yeah. Boosting, very good. Okay. Voting, stacking, boosting, bagging, variants of bagging, variants of boosting. Yeah. Oh yeah, yeah. There are different ensemble techniques. Very good. Wonderful, Kiran. Okay. What does stacking means? Combining different algorithms into one. Okay, not really. Meta learning. Okay. Use heterogeneous algorithm. Okay. Okay. Stacking basically is combination of multiple models. What we do is we combine multiple models, right? And we predict output. Same output, right? Same record, new record. We are trying to predict the output using different techniques. Now, what we do is we take these data as input for your meta model. These will be inputs, and what will be your output? Observed data. Observed value, which is y, actual value will be the output. So meta learning, meta model will take this as input, this as output, and it tries to predict the final output. So you will have supervised learning techniques trying to predict the output, but those output values which are obtained by these base models or base learners, their output will become input for the meta model. Right? So that's stacking for us. Now, what is voting? What is voting approach? Yeah. Going for majority, used for classification, combining predictions of different algorithms, weighted average. Okay. So voting basically is a technique which is applied for taking the aggregated output. It gives us aggregated outputs. All right. So we take either mean or median for the multiple models output. Right? We develop multiple models, and on each of those models, we basically pick up the output, and then we do aggregation. Now, voting can be classified into two types. What are the two types of voting? Hard voting and soft voting. Very good. So what is the difference between hard voting and soft voting? Hard voting and soft voting. Yeah. Hard okay. Hard voting basically means just take the aggregated result of the final output. Soft voting basically is going to look into the values of each of the output. For taking the decision in each of the model, we will look into the output, right? And based on the output, you are going to take the final decision. So those values are considered. In other words, we can say weighted average is used for soft voting, whereas hard voting is just the aggregated result of the final output of all the models. Right. Next. What is random forest, or how is random forest different from bagging? How is it different from bagging? Bagging is also a combination of multiple decision trees. Decision tree also has with replacement option. Reduces the overfitting problem. Bagging also does that. Very good. Kiran Kumar, very good. Funny Kiran, good. So the random forest that we are talking about is a variant of bagging approach. It's an example of bagging approach. In bagging approach, we are basically developing multiple models on the samples, and then those multiple models will be used for predicting the output or classifying the output, and the aggregated result will be used for taking the final decision. That is bagging approach. Now, a variant of this approach is random forest, in which when you are taking the sample data, in random forest, only a subset of columns will be chosen for a sample. When you are developing sample, when you are coming up with sample data, only subset of values are chosen. Right? So that is the primary difference of random forest with respect to bagging approach. Okay. What else? I think nav base we covered few questions yesterday, right? All right, fine. For random forest, what is the library? No. R package and Python library, guys. Python package. What are the packages used for random forest? Party, okay. Random forest itself is one of the libraries that we can use. Yes, now Preet, very good. With capital F. Random forest with capital F. And in Python we have sklearn.ensemble. Very good, Chaitanya. sklearn.ensemble. And the function we use is random forest classifier. Random forest classifier is used. Right, so that's about, let's say, random forest. Anything I'm missing? Okay, fine. Okay, what is the default number of trees used in random forest? Very good, 500. In R, for example, yeah. If we talk about R, yes, it is 500. But what are the default number of variables which are used? By default, what is the variable size that is used in random forest? Okay. Okay. Square root of p is okay. We also have p by 3. Two options. P by 3 is also there. So when your data is categorical, we go with p by square root by 3. Square root of 3, sorry. If your data is numerical data, then we go with p by 3 features. Very good. Okay. Fine. Okay, let me move on to the regression related questions. One of the very, very popular techniques. Yeah, Suresh, I was about to. So we'll move to regression techniques. A lot of, as I said, this is the most popular, regression is the most popular explainable statistical model, which is used for predictive analytics, right? And yeah, these are the interviewer's favorite questions as well. So before that, let's take a short break and come back. So it's 11:31 now. Let's connect by 11:38. Yeah. Okay. Hope everyone is back. All right. So now let's talk about the regression related questions. When do we go with regression? Yeah. We can also go with Canon. We can also go with decision tree. Linear, not really, not required. Linear correlation, not really, right? No. When output variable is numeric in nature, we apply regression techniques, we go with regression techniques when output variable is numeric in nature. Right? Then what regression technique we apply when output variable